Okay, having looked at that sine x over x, seeing that it has a limit of 1, even though it's undefined at that point. The limit is what's happening with the function values as you get close to that. You can read this box for yourself here. The limit as you approach a value, as x approaches some value a, right? The limit of this function as you get closer and closer to a means, if you're saying that limit's L, it means the closer and closer you get to a, the more the function approaches that value, even though it may not be defined at a itself. As it gets closer, the x with the little arrow a, this means as it approaches from either side, from both sides. We're going to look at three things here, and this might help you decide or help you understand. The existence of a limit doesn't depend on how the function's defined. All right, if you look at these three, they're very similar functions. The third one I'm sure you can graph on your own, but we can just really quickly make some graphs on a calculator here. Let's do the simple one first. X plus 1. I'm going to zoom decimal just for simplicity here. I'll get the axes off, of course. Turn that back on. All right, there's that graph. Let's do that. Oh, look, I put it almost right where I wanted. Unbelievable. Come on. Now, we'll do the next one here. Now, the middle one you can't really do on the calculator, but the first one you can. Alright, so instead we want now, you're going to need brackets here, x squared minus 1 divided by x minus 1. Look at that graph. Okay, something to notice right here. Okay, missing value happens to be when x is 1, because that's what's happening over here. Alright, let's get a picture of that so we can write on it. And we need the third one in the middle. The third one in the middle is essentially this graph here, but it's got a point defined for that hole. Okay, so I'm going to use the same one in the middle. But so this says everywhere where x is not 1, it's equal to this. So it's the same graph. When x is equal to 1, it says it's 1, so it's like this. If you were to draw this, you would draw it with a hole in the graph like this and like this. The calculator shows it like that, but that's how we would draw it with that empty circle. All right. So you have those three graphs. We're going to look at now what happens as you approach 1, this value on each of these functions. You're not asking what the value is at 1. You're asking, how does the function behave as you get close to 1 from each side? So we're saying the limit as x approaches 1 of this function, perhaps this is the easiest one to look at. Where does that function head for as you get close from either side? So as x approaches from either side here, what happens to this? This is zeroing in on what value here? 2, right? This limit is 2, because the closer you get to 1, the closer x gets to 1, the y value gets closer and closer to 2. What about these other functions here? This first one here. As x gets closer to 1 there, what's happening with this? Same thing, right? It's heading towards 2, even though it's not defined, even though that function is not defined there. This limit is the same thing. All right? This limit, as x approaches 1 of that function, f of x, is also 2. What about the one in the middle? This is got a different point there. As the function gets closer and closer, as the x value gets closer and closer to 1, what's happening with the function? It's heading for 2, even though there's this point defined at 1. It's headed for 2. You need to realize that the limit doesn't matter that this is defined as 1. The function is headed for 2. That's what its limit is. Its limit is 2. Okay, the limit of all of these. Limit as x approaches 1 of that function, g of x equals 2. Okay, so this is the important one. Especially this one. Limit is 2, even though g of 1 is 1. The limit as you approach 1 is 2. The function heads for 2 even though it's defined as 1 there. Now here's a bunch of complicated stuff down below here for you to look at. It's pretty simple stuff. If you have two functions added together and you want to know their limit of the sum, if you know their individual limits, if you know one function has a limit of L, some number, and the other one has a limit of M, if you combine those two functions together, you can add their limits. The limit of a sum equals the sum of the limits. Okay, think about the words and it makes sense. You can write the same thing for these other ones here. The limit of a difference is the difference of the limits. The limit of a product is the product of the limits. And so on. Have a look at what those are, and you can start to make use of them and stuff as you look at functions. Well, we're going to use them here. If you have here, you have three pieces. I mean, you can look at it as a single function or three functions combined together. You don't need to think about the graph now. In light of what we looked at here, if you have a function, whether there's undefined points or not, if it's a simple function like this, if you want to know the limit, you can just sub the number in. The limit here was 2. We could have just, without even looking at the graph, we could have said, well, if we want to know the limit when x is 1, we could put the 1 in there. 1 plus 1 is 2. The problem is for these type of functions here, when you have problems subbing it in. If we want to know what the limit is here when x is 1, this is the problem. If we sub it in, we get divided by 0 here. We get 0 divided by 0. What you can do is, since for this kind of a function here, if you can, I'm not sure if you've looked at functions like that before, but if you take that function is equal to, I get over here somewhere, that function is equal to x plus 1, x minus 1, divided by x minus 1. If you simplify it algebraically, if it simplifies to something else, right, this function is the same as that function, x plus 1. This f of x, though, has, it's the same function but multiplied by x minus 1 on the top and the bottom. All that does is create that hole in the graph. It's the same as a line with that hole in the graph. If you can simplify it, you can see what the limit is and then sub it in. So that's a pretty important concept to know, that if you can algebraically simplify something, you can do that and then find the limit of something by substitution. Alright, this first one, you don't even need to simplify it because you can already substitute it in. There's nothing that's undefined or anything like that. If you want to find the limit of that, it's just going to be equal to whatever 2 to the third is, plus 4 times 2 squared minus 3. I'll leave that for you to figure out. Whatever that value is, that's the limit. you could graph that function and just confirm that it's headed for that. Try some of the other ones. Starting here, you're going to have to simplify.